Time to wake up. Yeah.
That looks pretty good. Yeah, had a bit in the way, but should be right. Should be right. Okay. Yeah, well, can you look at you on that? Yeah, can you do that real quick? Oh, actually, no, yeah, so up to you, you can either send it, you have to send it to this man's email, right? So you can either look at your email there, or you can just transfer it. It'll be easier. But you still have to send it to him. Oh, yeah, then. But you still, then you did send it to yourself. Just send it to yourself. Yep. Oh, this is the wrong one.
Fine.
I'm not sure.
在这个是，那会儿你要这个是。 Sorry.
That's just yours.
It's
just your information, right?
Yeah, yeah. Okay.
Wait, could I also send my PowerPoint to you?
Okay, I see.
Thank you.
YYKO.
Just open up the Zoom, just open up the Zoom, I have the, meeting ID and also the password. So you can-
Oh, perfect. Someone's
Open
got
up
it.
the Zoom.
Been asking for this. Where are they?
Here is the meeting ID.
8310291.
I'll give you the permission to be a host,
Mhm.
so that you can share your screen.
Yeah.
Yeah. You can just have a random email, that should be fine, but yeah.
Recording in progress.
Have you downloaded other people's slides?
Not yet. Just
Okay,
mine.
okay, so give me a second, let me think where I can find the information.
OneDrive.
No, we have a share folder so that you can download all the slides into local, and then we can do the
Can
presentation.
you please log out my account?
Yeah, sure, you can log out.
Okay.
I have to think where I can find it, give me a second.
Anyway, mine is
I think we can find, let's see, the web conference. www. We are looking for the size, so.
Yeah, I'll send it to you. There you go.
And let's see in the full schedule. Here should have a slides. This is instructions, okay.
Okay, I'll send it to you.
And then, day 5, this is a 10:30, right? This should be session.
There's one session.
Which session?
Okay. 32.
Okay, 30, sorry. My bad. Where's the download button?
Next to the presentation.
Oh. No. Anyways, yeah, I'll download each one by one.
You need to sign in. No, that's the one. Each, you can't download all of them.
Download. What's it download? Allow. Home. Define here. So which one is your size? Yeah, which one is 2540, right? Okay, so this is your slides, and let's say do the presentation from current slides. You can use the presenter view. Oh, no, you can use that. Oh, so what's the password for that? What's the password for that? No, I think we have a password. Okay, sleep. Oh, that's correct.
Thank you.
Thank you so much. How you know the password? Okay, anyways. I think the problem is they can't use the presenter view, so. Yeah, that should be the, I can't remember, should be Control plus P. No, yeah, I see. Do you know,
Got
do you-
another screen.
yeah, do you know, yeah, so, that should be in the settings. Display settings,
Well, no,
multiple display detect. No, this says only have one display.
yeah, it's mirroring,
Okay,
so we
so
can't do it.
how about the project?
No, this is control.
But they don't have the presenter view. Cause they write some script.
We've got here just, this is mirroring that one.
Yeah.
Yeah.
How to set, I think there's a
This
screen.
this is giving one screen here and the two projectors.
You just give me a second, let me search, what is the key for change the display setting on Windows? Cause I'm normally using mic. Windows plus P, yeah, that's correct. So that should be the extend, all right, we change to the extend. This is working.
It's mirroring. It's just one output,
Yeah.
so it's mirroring the same.
Who is the presenter? A bad news is you don't have the presenter view, so you probably need to, have your own computer.
You can have your notes on your own laptop next to you
Yeah,
and the presentation.
yeah, we're sorry about that. You don't have the presenter view, but normally in the room you have a presenter view. Yeah,
Let's share.
but that's what we can do. Yeah.
Let's share. So it's gonna be a full presentation of projector.
Yeah. Let's show. Yeah, the rest is working, but the only thing is you don't have the presenter view.
Do
Yeah.
you have any audio coming from the presentation or it's just? Do you have any?
要用自己笔记本的话，其实可以有那个演讲者模式的，
我真的不是这么太麻烦，
那
就搞不完啊！我靠，兄弟，你这还有3分钟开始啊？哪个？是吧？这个啊，对，小段母。
这个没有演讲。
So the video is gonna be played. So video.
The video is working and
Okay, so we need to presentation.
Yeah,
and then
yeah.
go to Zoom. Anything else?
from the current slide. And
Yeah, we need to share this through Zoom.
yeah, share this.
Oh,
Share
is it
the screen.
shared?
I have already shared the screen. Yeah, you should be fine.
Need to mute this muted.
Yeah. We have a Mac in the back.
So
I think that should be ready to go. And the only thing is how can I hide this bar?
I think we need to go to
It is in there.
Zoom settings. And choose.
Let's stop sharing first on some settings.
Everyone's.
Where is the settings?
So it's
Let's
really-
reshare it again, because sometimes it will disappear. And I have no idea why, but that's how it works.
The small one.
Yeah. Sometimes it will disappear, right? I have no idea why, but definitely don't care about it. Just work like this. Okay, so it should be set up. Just give us a few more minutes. Let's do a final. Alright. 你用手机登下这个动作，你用手机登下这个动作，然后试一下这个过程是多么。我这上面手机上有一个模式，因为我是 Yeah, we will do the final testing. So I have my own phone and I will join the meeting and I will test if this is working or not.
So let's do. If you feel like something is more. First to.
So that open this. That's one
Question. Testing 1, 2.
Definitely you can give a call close, you can tell me where to go.
Are there speakers for this session? Okay. Hi, I think I'm the. Okay. So. So wait for the first one?
Yeah, great. You're the last.
You're the last one? All right. What about the first one? Mice? That's you? Yes, okay, good. And then my name is referred says the second one. There's one.
It's not you.
And then the third one. Yeah. The disparities and chain of factors. All right, so I will give you like, I'll show you 3 minutes left and then 1 minute left. 1, 3 and 1. No, from the 15 or from the 12. From the 12. Yeah. The 12, presentation of 3.
Okay, another information is the computer cannot use the presenter view because normally you have to write some manuscript. I don't think so because from the instructions, we required our own laptop to be on the back and we have to use the host. Yes. So that's the bad news. So you don't have the presenter view and hope you, but definitely you can, put your Mac in here and, look at the screen. All right. So that's the bad news for you guys. Yeah, so that's basically what we are doing. And yeah, we'll do the final check. And after the final check, we are ready to go. Right. Test, test. Okay, cool.
On this one, you'll see the connected, just based on the. And then, the speaker, you come on, just to show. So it's gonna be. And that's one.
How do we change the slides for the?
Okay, so there is a clicker.
Before we start, please ensure that you have already make the recording, all right? So if you want to change the slides, you can just close it. And then we have some slides in the, I think in the desktop, right? It's not in the desktop. Okay, so it should be in the download. It's in the download.
Okay.
Open them, do the presenter view or do the yeah, just presenter view and they should be ready to go.
All right.
Right.
Should be shared through.
Yeah, and from current slides. hit the
But
right-
this is not the first talk.
So who is the first speaker? So what's your,
It's mice.
okay, so it should be the first one.
Yeah.
Slides two from current slides, give us, one last minute. We have to ensure it is.
It's working. So you've got the clicker here. And there is a laser if you want to indicate so.
Yeah.
So there's a clicker here. Just check it, it's working.
Oh, I
And
see.
there is an indicator if you like a laser.
Ready to go? Okay. Hi, everyone. So we have a session on Webmining3. It's people, platforms, and personalization. We have 5 talks. I'm Daniel Romero from the University of Michigan. I'll be chairing the session. So for the speakers, I will tell you when you have 3 minutes left and 1 minute left from the 12 minutes. And then we'll have 3 minutes, up to 3 minutes for Q&A. And we'll go ahead and get started with the first one.
Hi, everyone. I'm really happy to share with you about our recent work. This paper is called Mason Methodology Inheritance for Social Media-Based Stressor Estimation. I'm the first author, Xin Wang, and the other authors are researchers from University of Oxford, Tsinghua University, and Beijing Normal University. Firstly, let me give a brief introduction for this work's background. As we all know, mental health has become a common problem all over the world, and excessive psychological stress is a main leading cause of mental health problems like depression, anxiety, self-harm, and suicide. Therefore, timely detection of stress is very important. The majority of existing social media-based stress detection works can be divided into 2 parts. The first is stress state classification, which is a binary classification to classify whether an individual is stressed or not. And the second is multiple class classification task to classify individuals' stress into preset categories, such as stress from school, the stress from work, and stress from financial state. We argue that to provide more effective treatment of stress relief, it is necessary to have a thorough understanding of the specific cause of stress. Psychological research has proved that stress arises from stressors. The figure shows 2 examples from which we can say that the first user's stress comes from exam and the second user's stress comes from writing paper. So exam and writing paper are stressors that cause their stress. This inspires us to go further about the stress detection to estimate the specific stressor. There are 2 challenges for building an effective stressor estimation framework. The first is that the user's stressor are quite diverse, with many long-tailed stressor classes containing a few samples per class. And the second challenge is that new stressors appear as time progresses. For example, the COVID-19 is a stressor appeared after 2019. Therefore, our method must have the ability to learn the latest stressor quickly and avoiding the forgetting of previously learned or frequently stressor in the training data. Based on all the mentioned motivation and challenge, we do three things in this work. From the task perspective, we propose a new task aimed at enhancing human well-being, which is called the social media-based practical scenario of few-shot stressor estimation task. This task is unlike previous stress classification task. It focuses on estimating the specific cause of stress and enable us to provide more targetable support for stress relief. We define this task with the challenge that are more practical. And from the method perspective, we introduce mental learning based stressor estimation task, which incorporate a special designed mental knowledge inheritance mechanism. Our model has strong generation abilities, so it can evaluate estimate the new stressors with a few labeled samples and solve the problem of catastrophic forgetting. And from the task perspective, data perspective, we create a stressor-oriented data set that contains 4,200 manually annotated posts. We believe that our public available data would enable future research to facilitate human well-being. And now let's introduce the task definition. Stressor estimation is a sequence labeling task which aim to identify the specific stressor. To be more specifically, if we input a social media post, the stressor estimation task is to learn a mapping function to get the corresponding label sequence which contains stressor information. And as we focus on the practical scenario, that new stressor continue to emerge over time, and some long-tailed stressors has a few labeled data. So we define our task as a practical scenario of few-shot stressor estimation task. Now, this task needs us to treat the model with past time period data and estimate the latest time stressors with a few adaptation data. As shown in the figure, our method contains three parts: the basic estimator, mental training process, and the mental testing process. And as shown in the figure, the basic estimator represents the model structure, consists of pre-training model and the conditional random field. The pre-training model is to encode the text, and the conditional random field is to decode and learn some constraints to avoid unreasonable output sequence. And the mental training and testing process represent the unique training and testing process for our basic estimator. In the mental training stage, we adopt two-level learning. The first level is to update the task-specific model, which quickly acquires the task-specific knowledge. And the second level learning is to get a mental model, which slowly summarizes task-specific knowledge as a generic knowledge, so that the mental model has very strong adaptation abilities. When adapting the mental model to a new tasking task with a few labeled samples, it will suffer from the problem of catastrophic forgetting. That is to say, the learning of a new task will cause the model to forget some of previous learned knowledge. We argue that the previous knowledge is important for estimating stressors in the latest time period, because in addition to new stressors, there are also some common stressors in the latest time period. Knowledge from the previous task can help our model effectively estimate these common stressors, so it is essential to avoid catastrophic forgetting. To solve this problem, we propose a meta-knowledge inheritance mechanism to generate an inheritor model, which consolidates the knowledge from the meta model when adapting to new tasks. Specifically, we define a knowledge inheritance loss for the meta-knowledge consolidating, and the core idea of the knowledge inheritance loss is to make the inheritor model imitate the prediction result of the meta model on the query side. And we revise the overall adaptation objective, which is a summation of knowledge inherited loss on query side and CRF loss on the support side. The meta-knowledge inherited loss and the revised overall adaptive objective is a key innovation of our method, which differ our method from the existing meta-learning methods. And one significant challenge for this new task is the lack of available data set. So we construct a social media-based stressor estimation data set. Each post in our data set is annotated by 3 psychological master students and reviewed by a psychological expert to ensure quality. The data set consists of 4,200 well-labeled posts from June of 2018 to June of 2022. The figure is a statistic of the data set with half year as the time interval. We compare our method with both traditional sequence labeling baseline and a few short sequence labeling baseline. The experiment shows that our method achieve over 4 to 5% improvement compared with the best baseline across different few short settings. This verifies that our meta-learning method with meta-knowledge mechanism and the further evaluation study shows that there will have significant delay if without entire meta-learning or meta-knowledge inheritance mechanism verifies their importance. We do further experiment under catastrophic forgetting setting. We can see that our method outperforms the best baseline over 8%. And this verifies that our proposed meta-knowledge inheritance mechanism can effectively resolve the catastrophic forgetting problem when learning a new task. And we also conduct parameter study. We can see that our method's performance fluctuation is less than 2% with different parameters. Which shows that our method is relevant, insensitive, and robust to the change of parameter settings. We provide 2 real-world cases as shown in the figure. In the first example, our method correctly identifies the user's stressor as monkeypox. The monkeypox is a new stressor for the framework. So this verifies that our framework can estimate the latest stressor with a few samples. And in the second example, our framework correctly identifies the stressor as decoration, which is an infrequently appeared stressor in the training data. This highlights the importance of our proposed meta-knowledge inheritance mechanism. That's all of my presentation content. As last, I want to say as stress-caused mental health problem has continued to increase all over the world, so that we hope this work can further facilitate to use some web data and artificial intelligence technique to help address this critical issue. And if you have any question about our paper, we are welcome to get in touch. And thanks for listening.
Okay, any questions? Any questions?
Thank you very much for the talk. I have one question about the data set actually.
Okay.
Like the result, most of the result is show like the data actually show like have the word stress in the data actually. Is it true for like the all data, like in the text?
It's text, only text.
No, is the word stress is included all that in all the data set, like in your data set actually for all entries?
Sorry, could you give more explanations?
So the example is show actually, it has the word stress in all the examples actually. Does all your like the manually annotated data actually have this word stress actually?
I see. I understand your question. The answer is yes, each post at least has web stressors, and there are some cases that the user express multiple stressors in web post, so that there will maybe more than one stressors in the samples.
Can you maybe say a little bit about what you envision the application for this would be? Like what can we do if we can actually identify the stressors from social media?
I think it's a really practical question. I think the first thing is that this program can support some psychological research on large population. You know that the psychological and mental health research, they often do experiment on maybe lower than 100 participants, so that we can use this to get some new stressors and the distribution of stressors for their research. And the other practical application is that I think this can we can preset some very dangerous stressors for teenagers, so that if the school or their parents know about this, we can alter them to avoid some tragedy happenings. I think there are these are two main applications. Thank you.
Thank you. Any other questions? All right, if not, let's thank the speaker again. Okay, do we have the speaker for the second talk, mining user preferences? Yep, all right.
Which one is your presentation? 我啥呢？2800就行了，这个。
Hi everyone. I'm Ray Wang from the Nanjing University of Post and Telecommunications, a text analytic and mining group. Yeah, it's my pleasure to be here and introduce our work, mining user preferences from online reviews with the Jerry, a weird personalized neurotopic model. An e-commerce review often reflects the valuable user Jerry interests, and these reviews are important for mining the user preferences. Okay, let's look at the figure. This figure shows the reviews posted by a user to the multiple books with various genres. This here genres means the categories of the books labeled by Amazon. Yeah. The review on the left indicates that the user is interested in the business and money and management and leadership genres. Okay, the right review is about the health and fitness and dieting. Okay. However, some seldom work has been done to provide the personalized topic profile to indicate the user's preferences. In this paper, in this paper, we represented the personalized topic profile with a list of words, maybe the list of 10 words or a list of 20 words. Okay. Although topic modeling, such as the latent derivative allocation and its neural-based variants, such as the NVDM, ATM, and contextualized approaches like the CWTM and CTM-NAG, they are widely used for mining semantic patterns from text. However, personalized topic modeling is relatively underexploited. A tool of best knowledge. Only Liu proposed the NPTM model in the CICAM 2023 to model the personalized topics for social media text and social media users. Yeah. However, existing approaches has limited limitations in generate aware personalized topic modeling. NPTM often generates meaningless topics that share low correlations with the product gerins. Yeah. Other models, such as the LDA and its neural variants, often fail to produce the personalized topic profile as the absence of the user modeling module. Okay, so in this paper, we propose the novel genre-aware neural topic modeling. We call it the GPTM. A GPTM could mine genre-aware topics that are semantically consistent with the gerund categories. Besides, it could also provide a personalized topic profile for each user to reflect their gerund interests. Okay. Okay. Let's look at our model. Our proposed GPTM. It mainly contains the two components, which are the text augmentation and representation module, text inference and generate contrastive module, the preference inference and the user contrastive module. Finally, it contains the prior matching module. In the text augmentation module, for each review XIU posted by the user U to the item I, we will first generate the augmented text and with the one-net synonym replacement. In the modeling process, to incorporate the gerund information, we first generate the embeddings ED here. It means the embedding of the gerund descriptions. Yeah. To pay more attention to the words relevant to the gerund categories, we compute the attention weights based on the semantic similarities between gerund embedding and the contextualized word embeddings. Okay. Finally, we could generate the gerund aware text representation here. It means the EX for the augmented text by weighting the contextualized word embedding with the attention weights. Here is the text augmentation and representation module. Topic inference and gerund contrastive module aims to infer the document topic distributions for the augmented data. And it also conducts the gerund contrastive learning. Concretely, for the generated text representations, these two are the gerund-aware text representations. We infer the document topic distributions theta, here, theta with the topic inference network IT. Then we could conduct the gerund-aware contrastive learning in topic distribution space. We construct the positive and negative pairs with the document topic distributions of paired augmented text and the augmented text with different gerunds. Then we could conduct the gerund contrastive learning to optimize the topic inference network IT by pulling the same gerund docs closer and pushing the different gerund docs apart from each other. Preference inference and user contrastive module. This module aims to infer the personalized document topic distributions and conduct the user contrastive learning. In detail, we use the user inference network to map the users to the preference distribution of the user. And from the personalized document topic distributions with the inferred topic distribution. Following this, we could conduct the user-aware contrastive learning in the personalized topic distribution space. Yeah. Here we construct the positive pair and the negative pair with the personalized document topic distribution from the same user and the different users with different gerunds. Following this, we could conduct the user contrastive learning to train the user inference network by pulling same user dogs closer and pushing different user dogs apart from each other. Finally, to ensure the interpretability of the mind topics and topic profile, we model topics with a dirichlet prior, and we use the maximum mean discrepancy for the prior matching. Our proposed GPTM follows the two-phase training paradigm. In the gerund-aware topic modeling phase, we optimize the topic modeling objective to train the topic inference network and extract the gerund-aware topics. In the user preference modeling, we optimize the user modeling objective and to train the user inference network and generate the personalized topic profile. To assess the performance, we conduct experiment on 3 Amazon datasets. We use the CP, CA, MPMI, UCI, and UT metrics for the topic quality evaluation. Also, we propose some metrics such as the GDR, GTC for the topic for the correlation to evaluate the correlation between topics and gerunds. For user preference modeling evaluation, we propose the personalized hit rate, personalized gerund correlation metrics for evaluation. We select nine state-of-the-art topic model approaches as baselines. Okay, here we present the topic modeling evaluation results. We could find GPTM outperform all the baselines in coherence and diversity metrics. This may be caused by the factors that contextualized information integration of GTM helps to improve topic quality. The dirichlet prior is helpful for the better interpretability. Okay, at last, contrastive learning in the GPTM will prevent the model collapse and ensure topic diversity. We also choose the correlations between the gerunds and topics. We could find that GPTM achieves higher GDR value and GTC values. That means that incorporating gerund information will enhance the correlation between topics and the gerunds. Okay, we also present the user preference evaluation results. From the table, we could find GPTM outperforms NPTM across all the datasets on the personalized hit rate and personalized gerund correlation metrics. This may be caused by the topic modeling. Okay, topic modeling helps GPTM to mine gerund relevant topics, and the user inference network could generate accurate preference distributions for the users. At last, we also visualize the user preference distributions and the document topic distributions. We could find GPTM generates the distinguishable topic distributions for users, while NPTM could not. Left is the result of GPTM. We also could find user preference distribution generated by GPTM are located closer to the topic distributions. Okay, in this paper, we proposed the novel generalized aware personalized topic model. The general aware constructive learning on the GPTM ensures the relevance between topics and gene categories. User aware contrastive learning of GPTM is helpful for accurate preference modeling. In the future, we will explore how to leverage large language models for user preference modeling. Also, we will extend GPTM for dynamic preference modeling over time. Okay, thank you.
Questions?
Hi, thank you for the talk. I had a simple question just about, can you, so I think I understand standard topic modeling, you assume documents is a mixture of topics.
Yes.
Can you explain again, just very simply, like how the user component is kind of comes into this model?
Okay. You mean the user component? Yeah.
Yeah, because like, so I think like standard topic modeling, document is modeled to be a mixture of topics.
Yes.
So
yes.
how does, can you maybe just say again how the user component, how the users are modeled in this generative model?
Oh, okay. Our model is the two-phase modeling approach. I mean, if you use in the first phase, if you use the LTA, I think it will be okay. Our user modeling parts can be incorporated with any traditional models. Yeah, I think it will be okay.
Other questions?
I want to confirm my understanding, which may be wrong, that you're using genre to refer informally to the subject matter. For example, starships and as opposed to horses.
Yes, yes.
Because normally in publishing, genre refers to the shape of the story or the underlying subject matter, such as the conflict between what a man's got to do and what society demands.
Yes, yes.
So you're really talking about topic and vocabulary rather than the shape of the story.
The general here is labeled by the Amazon to the lab. You may see it as the labels of the item reviewed item, like books. It means there are many categories of the in the books, such as the children's book and the education's book. It means here
you're using the marketing categories as ground literal.
Yes. We only use the description of the categories. It's text input. Yeah.
We'll go on to the next talk. So let's thank the speaker again.
Second. So which one is yours? 1732. Oh, that's 1732. That's correct. Okay, so it should be this one. Slide 2 from current slide.
Should I start? Okay. Thank you very much, everyone, for joining the presentation. Today, I'll talk about digital disparity and how it shaped the user experience on web across the economic boundaries. This is a joint work with researchers from CISPA, Nokia Bell Lab, and NYU Abu Dhabi. Now, according to the data, currently 67% of the world populations are connected to internet, which is a big milestone for us, although this access is not equal. For example, 93% of the populations in developed world is connected to internet, while this number is only 60% in the developing countries. And this disparity also influence how people access and engage on web. For example, a study shows that most websites visited in countries are local, not the more popular ones or the global ones. Now, raise your hand if you think the more than 80% of the website in the Tranco top 1 million are from in developing world, which represent the 80% of the world population. Okay, interestingly, that's true. Only 23% actually represent the developing world in the top 10 to 1 million, which is used in most research. That means most of our research in the accessibility, security, or privacy actually. We focus on the developing world while overlooking a large portion of the web which belongs to the developing part. Now, the question is, what's happening in the other part? Are they lagging behind? Are they inaccessible? Are they less secure? Or they are adapting in a different way?
To answer this question, we start with a general commonly held premise that, okay, the developing websites from the developing countries are typically lag behind from the developed one in size, meaning that the website is small and simple actually because they do not have the enough resource. In security, because of the limited cyber security measure, so it makes them more vulnerable. In privacy, because of the weak privacy law and use of the tracker and the cookies. In quality, because of the poor optimizations. In tech adoption, because of the limited use of API. And lastly, in accessibility, because of the inadequate focus on the accessible web design. Now, due to time limit, actually, I will only focus on some aspect of the result. Please check out paper for more details. Now, the first question is, how do you define the developed and developing countries actually? Which country should belong to which group? Now, there are multiple definitions, but we use the IMF definition for the developed or the advanced economy and developing economy. And from each group, we select the top 10 most populous countries. On top, we have countries like the US, UK, Germany, which represent above 900 million people. And on bottom, we have the developing countries like China, Bangladesh, India, and Pakistan, which is home to over 4 billion people. Then to select the country-specific website, actually representative website, we utilize the Google Crux dataset, which the Google Chrome team publish every month, collecting the real-world user experience of the Google Chrome browser. And then from there, actually, to select the country-specific website, we use two signals. The first one is the country level TLD. That means, like, for example, .de for Germany or .bd for Bangladesh. And the second one is who is data information, which gives the registration information for the website actually. That's why in our example, the third website actually uses a generic domain, but it registered in Germany. That's why we include in our German list. Then we use the Google Lighthouse for the performance auditing and the Puppeteer to automate our crawling. And after the testing, we select or save actually all the files like HTML, CSS, JavaScript, and the header and everything from the website actually. And this process is repeated until we get 10,000 websites, successfully get 10,000 websites for each countries, which gives us in total rich data set of 200K website in total, including all the header and all the files from the website. Now let's move on to the result to see if our premise was right. We start with the website size, and our result shows that the developed countries' websites tend to be larger with a median size of 3.35 megabyte compared to 2.99 in the developing one. Interestingly, both of them are larger than the global median actually, which is around 2.4 megabyte. Now, not only the websites are larger in the developed countries, they also tend to use more number of requests actually. On median, they use 19 more requests than their counterpart. Now, this number is very important actually, because most of the population in the developing countries use mobile and the slow network to access the internet. That means a lighter website with a fewer number of requests is a big plus from them. But to understand actually what is driving this difference, we need to look into the specific component of the website. This figure shows the breakdown of the website resource actually used by the website. On top, we have the third-party request. And you can see that developed countries use 20 to 34% of the resource for third-party request, while the developing countries slightly lower, 20 to 27%. But the main difference came from the image actually. While the developed country use around 30 to 40%, the exception is Korea actually, which is almost 50%. The developing countries is use significantly higher actually. For in almost all cases, it is above 50%, almost above 50% for only for image. But interestingly, if you look at the number image bandwidth for per website actually, we can see that the number is very close in both group actually. But the developed countries website use 5 more image per website actually than their counterpart in the developing world. Which means that the developing countries website use fewer image, but they are larger actually. Which brings us to the optimization part, because the larger images are not necessarily optimized one. And by optimized format, I mean the modern format like WebP, AVIF, or JP2, which use significantly lower image size for the same quality than the older format like PNG and JPEG. And our results show that the developed countries use 28 to 40% of the optimized format. Exception is Korea actually, they use a lower number.
In compare, the developing country use lower percentage of the optimized format, like 18 to 30%, which actually confirms our previous hypothesis, previous assumption that those image formats are less optimized in the developing part. Now let's focus to the security, because a fast website actually is useless unless it is secure. And we start with the adoption of HTTPS protocol, and which is the building block for the secure web communication, and it's supposed to be the norm by now, but interestingly, the real picture is different. And on left, we have we can see that the developed countries has adopted a much higher rate, actually, the HTTPS, but there is still a gap. For example, the 23% of the South Korean website is still is relying on the HTTP. On the other side, the scenario is a little bit is worse, actually. Like, for example, 20% of the Bangladeshi website and 20% of the Chinese website is still using HTTP. And if you look at the overall picture, we can see that the developing countries are clearly lagging behind, with 12% of the website is still continuing to use HTTP. And a recent paper from the Mozilla also confirmed this result, which shows the difference in the HTTP adoption in different regions. Now moving to the vulnerability detection. Now to detect vulnerability in the website, we first need to know what JavaScript that they're using. And this is the most difficult part in our pipeline because of the obfuscation of JavaScript and the minimization and also use of the bundle, actually. It's hard to detect the JavaScript file and JavaScript library, actually. That's why we use three signals. The first one is return.js, which actually analyze the JavaScript file and then gives us a list of the JavaScript libraries with their version number. We also use the custom regex, actually, to statically extract the library name and the version number. And lastly, we use Google Lighthouse internal dependency analysis to extract the library name and version number from the JavaScript files. Then we merge the result and remove the duplicate. And then we use the Sneak vulnerability database to look up the known vulnerability for each JavaScript library and their versions, which gives us the full vulnerability report for each website with the severity of the library. Now moving on to the result, we can see, interestingly, for 6 out of 10 countries, in the developed regions, the 10% of the website include at least one JavaScript library with high or critical vulnerability. Interestingly, this number is only 4 in the developing region. And even if we look at the overall combined picture, we can see that the developing countries website tend to include more vulnerable and JavaScript library in their website. And the previous result also confirmed this result, actually, which shows that 20 to 40% of the website actually includes at least one vulnerable library. Now we move to the privacy, actually, and especially the use of tracker and the third-party cookies. Firstly, we look into the tracker, actually, which is the website used to monitor the user. Most of the oftentimes without the proper consent. And this figure shows the number of tracker per website. And now there are 2 things I wanted to focus. The first one is the developed countries website tend to use more tracker, 3 more trackers actually on median from the developing ones, which could be because of the ad-heavy ecosystem in the developed countries, actually, basically. But even among the developed countries, the EU countries tend to use relatively less number of tracker in their website, which we can think of probably effect of the GDPR law in the EU. Now, for the third-party cookies, we can see that the use of the third-party cookies is relatively low, actually, across the board, and that could be which is probably the effect of the recent change in the Google Chrome browser cookie policy. But the Russian website actually is stand out in a dataset with the highest number of cookies used in the website. And the previous result study also showed the same result of the cookie use in the Russian website. So in conclusion, the developed countries' websites are smaller. They use fewer requests, but they tend to be use poor optimization, which that means like they're serving large images. That means like they're wasting more data. In security, the HTTPS adoption is higher in the developed countries, but they tend to use include more vulnerable libraries in their website. And also they use more tracker in their website, and while the Russian website tend to stand out with the highest number of cookie use. Finally, our data set with all the data actually is available on GitHub for future research and the collaboration. And also we found more interesting result for the accessibility part, which we're going to include in the paper actually. That's why we write another one. So you can also check that if you're interested. Thank you very much.
Do we have any questions? So I'll start with a question. Have you looked at any time trends for these disparities? Because I'm wondering if with the sort of use of AI and things like that, it can become cheaper and more effective to actually for developed countries to maybe close that gap. So I don't know. Like, have you seen time trajectories?
Longitudinal study.
I'm sorry.
Temporal study.
Yeah.
So we wanted to. Thank you very much. Actually, it's a great question. We wanted to do that for the security part actually. The problem with this is like we wanted to look at the 10 years or 5 years frame. The problem is the website in the developing region, actually the one we selected, although they are very popular in those countries, they are not available in the Internet Archive actually. Like many of them are not, like they do not have the data long back then actually. So the problem with those studies is that we could not find the enough number of website in the same in the two group to compare those trend actually. That's why we changed, we did not do that part basically. But this is a very interesting pathway actually. Maybe we can follow up in the future.
Any other questions? All right, let's thank the speaker again. All right, and do we have the speaker for the next talk? Yeah. Okay. The author is not here. Yeah, so we're told we cannot play the video because the chairs do not allow video talks. So we would not be able to do that. We just cannot.
The video will upload to the YouTube channel and
All right, so then we'll go to the last talk. And do we have the speaker for that, for the last talk? You're the speaker? Yeah, you can go ahead.
Okay, let's close this one. And what's the number? What's the number? 25 and 40. Cool. Okay, so yeah, we'll get started.
Okay, hello everyone. My name is Yoon Ko from Chunghang University, Korea. Thank you for all being here today. I'm so happy to present my work at this web conference 2025. The title of my presentation is Crown, a novel approach to comprehending users' preferences for accurate news recommendation. Let's get started. This is the outline of this presentation. First, I will briefly introduce the problem definition and challenges in personalized news recommendation. First, let's talk about what is personalized news recommendation, which aims to help users discover the news articles interesting to read by providing them only a few news articles aligned with their interest. Therefore, it plays an essential role in online web-based news platforms where users are usually overwhelmed by a massive amount of news articles. This figure shows the process of the personalized news recommendation. First, a user visits an online news platform and click and view some news articles. Then the system can analyze the user's preferences based on their log, user's history, and then it ranks the candidate news articles based on their the user's preferences, and finally it recommends only a few news articles that the users is likely to prefer to read. The problem that the personalized news recommender system aims to solve can be defined as follows. The click prediction problem. Formerly, given a target user with the user's historical click to news articles and a candidate news, the goal of this problem is to predict whether the user will click the candidate news or not. How can we solve this problem? The general approach to this problem as follows, involving two steps, news and user representation. In news representation, the embeddings of the news articles in a target user's click history are generated. And in user representation, the news embeddings generated in the previous step are aggregated into a user embedding. Then, given a candidate news article, which is also represented as a embedding to compute the probability of the target user clicking the candidate news article or not. Therefore, it is crucial to accurately model users' interest based on their historical clicked news article. So far, there are many of the existing works to focus on improving the news or user representation. However, in this work, we pointed out the three important but underexplored challenges. First challenge is about manifold intents. News articles can have manifold intents. Second, not all collected news articles can reflect users' true preferences. Third one is about the cold start users, which is the traditional challenge. Let's move on to the first challenge a little bit closer. A news article can be created with a range of intents. For example, weather forecast news aims to provide weather information and want to improve public interest. However, it is not interested in persuading people, right? On the other hand, the political news may aim to provide some information about new policy and persuade people to agree or disagree with the policy, but may be less interested in public interest. So the intents can vary across news article. Therefore, So for accurate personalized news recommendation, we need to carefully understand each of intents coupled with a news article. Let's move on to the second challenge about the varying post-read preferences. Generally, users clicked news articles are used in capturing the user's interest. However, think about, do all news articles in a user's click history reflect the user's true preferences? Think about the answer to this question. This figure shows the process of the news consumption. First, user view the news articles displayed with their title and clicked only news articles with the high pre-read preferences, right? However, the user does not always enjoy what they click. There are two cases. First, if the contents aligned with the user's expectation well, the user may be happy to read. However, sometimes the news title looks just appealing, but the contents does not match expectation. In that case, the user is disappointed and quickly close that article, right? However, both news articles are included in the click history and used for user modeling. So these articles that the user is unlikely to prefer can cause inaccurate user modeling. So we need to carefully differentiate news articles with different post-read preferences. So let's move on to the third one. Is about cold start user problem, which is the traditional problem in recommender systems. And most news recommender systems model a user interest based on the user's historical clicked news articles. However, there exists new users who have limited click history, which make it difficult to build an accurate profile. So let's move on to the proposed method. This figure shows the overview of our proposed framework, which consists of 4 modules. 2 encoding modules, news and user, and 2 prediction modules, click predictor and category predictor. In the news encoder, we try to address the first 2 challenges. And in the second encoder, the user encoder, we try to solve the third challenge, the cold start user problem. And finally, we use the 2 different tasks, click and category prediction task for model training. I will explain it in the next slide. First, let's talk about how can we address the first challenge. Our simple example is just to use category information, which is known to be beneficial to enhancing news representation. Let me explain the intuition behind this idea. Assume that there are 2 weather forecast news articles, each of which delivers different weather information, like sunny weather or rainy weather. However, no matter what they want to deliver, their intent may be similar to each other. Provide weather information and improve public interest, right? Similarly, assume that there are 2 political news articles, each of which might have different political stances. Regardless of their political stances, their intents are similar. They both aim to persuade people to agree or disagree with some policy, right? So we claim that the news articles within the same category have the similar intents, even though their content differ. To verify our claim, we conducted a preliminary experiment. We randomly selected 2 news articles from each of the 4 categories and compute the relative importance scores. So as you can see here, the news articles within the same category tends to show similar intent distribution. It means that manifold intents coupled within a news article are closely related to its category. So let's move on to the next challenge. How can we differentiate the varying post-read preferences? As I explained previously, the news consumption process is as follows. As you can see, the first case, happy to read case, read to long reading time. Okay, so and the case 2 lead to shorter reading time. It means that users' reading time can indirectly reflect users' post-read preferences. Our example, to use the consistency between the news title and contents. It means that the larger the consistency is, the higher the post-read preferences. So this figure shows the Pearson correlation coefficient between the title contents consistency and users' reading time. As clearly shown in this figure, the consistency and the post-read preferences are closely correlated. So if we leverage this consistency well, we may capture the post-read preferences successfully. So let's move on to based on the 2 ideas, we design our news encoder, which consists of 2 parts. The first part is the category guided intent mode. Given this the news article, we generate k-entangled these intent embeddings, each of each embeddings is corresponding to each intent. And then in the second part, the consistency-based news representation. First, we intend in the intents-aware aggregation, the k-intents embeddings are aggregated into single embedding, and then we compute the consistency, and finally represent the news embedding. Here, the news contents is differentially incorporated into the news representation. Let's move on to the user encoder for addressing the challenge 3. We can capture cold start users' preferences successfully by using the collaborative signal. In the case of the one user, probably enough to capture. We have enough information to capture their preferences. However, for cold users, we have insufficient information to capture the cold start users' interest. Our idea is just use the leverage collaborative signal, which is the complementary information from the user with similar interest. So this is how we design the user encoder. Our user encoder not only aggregate the embeddings of the clicked user articles, but also leverages mutual complementary information from other users. Specifically, we first construct the user use bipartite graph and update use and user embeddings based on GNN model, and finally represent user embedding. So, and as the task, we use the click prediction as the primary task, which is to compute the probability of the user clicking a candidate news article, and then which the laws from this task are used, the primary laws for model training. And in addition to click prediction, we incorporate a category prediction as the auxiliary task. It computes the category probability distribution of a candidate news article. So the predicted distribution is compared with the ground truth, and the auxiliary loss is computed. So let's talk about the law of these laws. 1 second. So these laws provide supplementary supervisory signal to guide the news encoder to be trained for better intent disentanglement. So this is the reason why we called our method as category guided disentanglement. Finally, the two losses are unified and our model are trained to jointly optimize the two tasks. So let's move on to the last part, the validation. We evaluate our model by answering the 5 questions. We use 2 widely used data set, and we compare 12 state-of-the-art methods. This is the experimental result. As you can see, our method consistently outperforms all competing methods in terms of the all metrics in both data set. And also, we also show that the effectiveness of our proposed strategies in terms of the news representation, for example, as you can see here. So as you can see here. So let's move on to the next question. Or as you can see, compared to the simple user encoder, our GNN enhanced hybrid user encoder achieves the best performance. And also we show that the effects of the auxiliary task. And also we show that our method achieved the best performance on the cold start user problem. Okay, this is the conclusion of this presentation. In this work, we pointed out the challenges of the news recommendation and proposed novel approach to comprehending the user's true preferences named CROWN. And we employed 3 different key ideas. And then in the future work, we consider LLM-based news representation, and we want to accelerate the news recommendation process as well. Okay, this is the end of today's presentation. Thank you for listening.
So we're over time for this talk, but if there's a quick question, we can take it since we have a little more time. If there are no questions, then we can conclude the session. Thanks everyone for being here, and let's give a hand to all the speakers again.
Okay, I hope everyone have a good journey in Sydney during your weekend, and hope I can see everyone in next year.